Welcome to Calculus in the AM. Nope, it's the PM. I'm your host, Mr. Shindalka. This lesson has been brought to you by the letter P and the number 3, and also by my local business. Winter's coming. Have you had your chimneys cleaned? Maybe you should consider that. I specialize in coal-fired chimneys. Coal is nature's fuel. And anyways, also brought to you by Douglas Chimney Sweeping Service. More about that later. Derivatives of exponential and logarithmic functions. You guys okay? The other day, we were taking a look, and we looked at graphs of the exponential function. And if you take the slope anywhere on these curves, and I gave you some specific spots, slope of the tangent line, you will find that the value of the function is the exact same as the slope of the tangent line. And another word for slope of the tangent line is the derivative at that point. The slope, that's what the derivative gives you, the slope of a tangent line. So that led us to believe that when you do the derivative of an exponential function, just the simple one, e to the x, the derivative is the exact same. It's e to the x. What's the second derivative of e to the x? E to the x. If I said y is equal to e to the x, and then if I said d3y by, I did that? No, I didn't do that. What would this be? E to the x. E to the x again. It goes forever like this, right? Okay. The derivative of e to the x is e to the x, even if you do it 5 times in a row, 75 times. Okay, then we looked at some of these, using the same old rules, product rule and so on. Same things hold true. Remember, if there's no variable in it, it's a constant, it's 0. Don't consider anything. Okay. Now, we said then, what if it isn't just e to the x? There's got to be more to it, and there is. Think of this as a composite function, 6x, and the exponent is the inner function, right? So we said, do the derivative of the outside. That's the e to the something. Then the derivative of the inside. I'm doing it in that order only because that's the way we were kind of like told. And I still think it through that way. Outside to inside. Layers, onions, ogres, right? Composite functions. However, when I actually write them down, I do consider it. I'll write down e to the 6x first and then do the derivative of the inside, say just 6. Because the norm is to have your numbers first, right? So the chain rule is, if you have e to the u, where u is some kind of function of x, still, it's the derivative is the exponential function written down as it was, same exponent, times the derivative of that inside. Okay. And we looked at some of these. This is where we left off. I said you could try the first one or something like that. Didn't know that you'd get heavy duty into this or not. Now, I also mentioned that, I'll give you some work time later, but I did mention that I would be looking ahead at some stuff though, too. And here's what I'm going to do. Just talk about, I'm just taking a look ahead here. The logarithm stuff. Well, I'm going to let you guys try a few of these, and in about 10 minutes, maybe 15, we'll take a look at the logarithm stuff, okay? So I'll pause this.